Okay, previously kita dah belajar a few things dalam my recorded last video I dah explain a little bit here and there. Okay, but right now I nak terus kepada sebab tadi kita dah belajar properties of concrete. So we know that reinforced concrete ada reinforcement and also concrete. So right now we're going to go to reinforcement. Okay, so as we know, bila kita pakai reinforced concrete, kita nak construct reinforced concrete, we're going to use a steel bar. Okay, steel bar macam ni lah rupa dia yang as what I show here. So here, you have a hot roll mild steel bar. Okay, ada mild steel bar. Okay, and FY ni, okay, so FY here, you nampak So FY, tak bestnya dia punya ni. Oh my god. Serius lah dia punya Webex punya ni seriously tak bagus langsung. You guys tak nampak kot what I'm doing. Alright, so FY here means adalah dia punya yield steel dia punya yield strength. So yield strength ni is actually dia punya kekuatan lah. Okay, so for kekuatan kita panggil dia FY. So this is the symbol for strength, for steel, FY. Okay, so the strength of steel for mild steel bar is 250. Okay, so this one you kena hafal. Kena selalu ingat lah. Okay, and then another one here, we have a hot roll or cold work high yield steel bar. So this one adalah high yield steel bar. So high yield steel bar, dia ada hot roll and also cold work. Okay, so I rasa you dah belajar kot about steel, so you know what is hot roll and what is cold work. Okay, so the strength is 460. So ini pun kena ingat jugalah. So ingat mild steel 250, high yield steel 460. Okay, so also kadang-kadang dia tak panggil high yield steel lah, dia panggil high strength steel ke macam-macam nama, but you dengar perkataan high tu meaning is very very strong steel lah. So contoh mild steel bar is here. Okay, yang kat sini you nampak mild steel bar is here. Okay, yang warna biru I bulatkan ni. And for high yield steel, this one. Okay, so ini adalah yang strong bar. So 460, kalau you nampak dia ada macam like corrugated line-line. So ini adalah high yield steel. Okay, this one is actually yang this one. Okay, square twisted cold work bar. Okay, so this one adalah this type. Okay, hot roll bar with transverse rib ni inilah. Okay, so the stress strain curve for reinforcing bar are shown in figure. So this figure, hot roll bar have a definite yield point. A defined proof stress is recorded for the cold work bar. So if you still remember, I pernah cerita pasal Hooke law masa part 2. We learn about stress. Apa yang you cakap? What did you comment? I tak nampak. Miss banyak cakap, tak dapat dengar apa-apa. Can you hear me? Guys, respond please. Right? Okay, some of you can hear me, some of you cannot. Why? Certainly not. Alright. So some of you boleh dengar, some of you not. So maybe nanti I upload lah. Mungkin you boleh dengar. Cannot. Weird. Mungkin ada you punya setting speaker kot. Cuba check balik. Alright. Apa tadi I cerita Okay, so okay, cerita pasal hook law tu. Masa part tu kita ada belajar how dia the experiment to measure the strength of steel reinforcement bar. Okay, so ini adalah dia punya hasil lah daripada the experiment itself, pakai that hook law whatsoever experiment yang dia pakai tu. So if you see here, nampak 250 fix here. So this one for mild steel hot roll bar. And also here you nampak yang panjang ni for high yield core work bar, and the one yang lebih what we call it, lebih stable here, we call it high yield hot roll bar. Okay, so ini yang 460. So normally yang kita tengah belajar, kita pakai high yield hot roll bar and also mild steel hot roll bar. So cold works bar ni dia macam jarang kita pakai, normally for specialized work ataupun something yang need more sebab dia lebih mahal high yield cold work bars ni. Dia more expensive and it depends on jenis kerja lah. Ada benda yang you kena pakai this high yield cold work bars but normally kita akan pakai hot roll. Alright. So the basis of design, so the design of reinforced concrete elements, kita belajar adalah BS 8110. Okay, sebenarnya sekarang kita dah start Malaysia, not really Malaysia lah, the whole world start using Euro code. Okay, however, masih ada lagi yang tak boleh move on daripada BS, so kita stick to BS lagi lah. It's not widely used Euro code. Okay, so the criterion for self-design in the structure should not become fit for use. For example, that it should not reach a limit state during a design life. This is achieved in particular download apps. Kenapa tak pakai? Aduh. Sorry gangguan. Sorry. Alright, apa tadi aku cerita? The criteria for safe design is that the structure should not become fit for use. Okay, so kita mesti make sure that the structure is safe to be used. For example, that it should not reach a limit state during its design life. So everything dalam hidup ni mesti ada limit. So sama juga dengan kita design. So when we design, we need to achieve a limit also. Maksudnya jangan achieve limit lah. Kita kena design tak untuk tidak sampai limit. Okay, so limit ni the maximum lah. So this is achieved in particular by designing the structure to ensure that it does not reach. So we have here the ultimate limit state and also serviceability limit state. Okay, so ULS here, what it refer to, so the whole structure or its elements should not collapse, overturn or buckle when subjected to design load. So ultimate limit states, it's more on to make sure that the structure tu tak jatuh, maksudnya selamat lah. Okay, so ultimate limit state more on looking into the strength of the structure itself. Okay, to make sure that it is fit to be used. Fit to be used tu bukan dari segi appearance lah, tapi fit to be used dari segi the strength itself, meaning it can sustain load as what it is being designed. Okay, and then we have the serviceability limit state. The structure should not become unfit for use due to excessive deflection, cracking and vibration. So serviceability limit state, it's more on appearance wise lah. Okay, so appearance wise, what I mean is that cracking itu tidak cantik. Okay, but cracking also can cause the structure to collapse. Okay, but excessive, terlampau crack. Okay, but Other than that, cracking itself is a nuisance lah. Nuisance to the eyes, nuisance to our surrounding Or vibration. So vibration is more on the aesthetic and appearance wise lah. Okay, so visibility limit state. But ultimate limit state is the one yang more on the stability and the strength of the structure itself Ayo. Why did it macam ni? Right. And then, okay, some of ULS to be considered are, okay, so as you see here, you are the empat, which are ULS due to bending, ULS due to shear, ULS due to direct compression or tension, ULS due to overturning. So we must make sure when we design a structure, dia tak ada this bending yang too much shear. So kalau bend terlampau banyak, lama-lama akan patah. Sama juga dengan shearing. Okay. If shearing too much, lama-lama you punya, for example, you are constructing a beam, so beam you akan patah juga. Okay, and then compression and tension, direct compression and tension ni also caused by forces. Compression force and tension force. So patah juga. Ataupun overturning, meaning that dia berpusing. Contohnya kalau you design for retaining wall lah. Contohnya as what you learn masa part 2. So overturning is bad. So ada factor of safety macam tu lah. Okay, so we must make sure that whatever that we construct, this is what we consider when we design to make sure it does not exceed the limitation for this bending, shear, direct compression or tension, and also overturning. Okay, and then we have SLS. So this is serviceability limit state. So SLS due to deflection. So deflection ni tak sama dengan bending. Bending can cause deflection, but excessive bending can cause pecah lah, maksudnya you punya beam putus. Okay, so for deflection macam yang you belajar masa part tu, just a simple, banyak besarnya. Okay, katakanlah this is like 1 mm deflection, tak ada, no effect. Okay, so tak ada effect, tak ada excessive effect pada you punya structure so this is still safe. Kenapa dia tak boleh padam? Clear my annotation. I cannot clear. Okay, whatever. Alright. So when designing a particular concrete element, it is usual to first ensure that the ULS is not exceeded, then to check the relevant SLS is also satisfied. But normally when the ULS is satisfied, normally the SLS will be satisfied also, sebab ULS ni lebih critical lah compared to SLS. Alright. Why? Okay. So, having identified the relevant limit state, the design process simply involves basing the design on the most critical one and checking for remaining limit states. This requires an understanding. 1, the material properties, and number 2 is the loading. So, material properties, actually I dah explain a little bit here and there about the concrete and also, apa nama tadi? Reinforcement. Okay, so dah explain. And the other one is loading. Okay, so I lupa nak tanya, ada soalan kah? Any question? Kalau ada soalan, you can stuck. Stuck, banyaknya stuck. You can ask here lah, dekat chat message kalau ada soalan. Alright. Kalau tak ada soalan, tak payah chat lah. But bila I tanya, you jawab lah Okay. Tak soalan. So I proceed Alright, so having identified the relevant, okay, ini dah settle tadi. So kita kena tengok material properties and also loading. So this one bukan I yang create sendiri, bukan I yang create all these clauses and whatsoever lah. So this one is definitely referring to BS 8110. BS 8110 ni kalau you Actually, I have lah the books itself. It's quite tebal sebenarnya. And boleh dibeli juga kat luar. And also ada juga yang share that BS 8110 kat internet. Banyak sebenarnya share dalam PDF Sebenarnya you boleh cari. Ada. Okay, so but since that one is being shared secara haram, I'm not going to share with you lah. You boleh cari sendiri. Google sendiri lah. You will see that actually there is a BS. Circulate. Okay. Alright. Apa hal dia balik-balik? Okay. So, sekarang baru kita masuk on the reinforced concrete beam design. Okay, so the beam section here, 3 common types. Okay, so you are the rectangular section. So, rectangular section is this one. Agak annoying lah juga benda ni sebenarnya. I want to annotate apa aku cakap ni. Okay. So, you nampak kat sini. So, here we have a rectangular section with tension steel only. So, apa maksud dia sekarang ni? Kalau you nampak dua biji ni. Kenapa dia tak nak annotate? Oh Lord. Okay, so you nampak ada dua bulatan ni. Okay. So that two bulatan tu sebenarnya adalah steel tension steel ataupun kita panggil dia as main bar. Okay. Main bar. Sebab bar yang main, bar yang penting lah. So dia adalah tension steel. Okay. So this one adalah cross section of beam lah. When you cut it, you akan nampak like this lah rupa dia. Alright, so for B, here, yang B, this one. So this is rectangular section, width section and compression steel. Okay, so here you nampak 3 biji ni. Okay, so 3 biji bawah ni is tension. Oh my god. 3 biji bawah ni is actually for... This is the annotation is very bad. I don't really know. Takkan every time nak kena tekan. Okay, so here for tension. Okay, but at the top here, so this one for compression. Oh my god. Tak boleh nak tulis. So compression Okay, so here is for compression yang top and bottom one for tension. Okay, so this one kita biasa panggil dia this is the first one yang kat sini kita biasa yang the A normally kita panggil dia as singly. This one kita panggil dia as doubly. Okay, singly and doubly. Single and double lah. Okay, so this one yang A is singly. Okay, only tension bar. But for B, it is doubly because dia ada compression and tension bar together. Okay, because as we know, kalau kita dulu kita pernah buat, kita belajar pasal bending stress, if you still remember. Okay, atas adalah compression, bawah adalah tension. So ini function dia lah. So bar atas ni adalah to resist, also help to resist compression. Dia tolong concrete to resist compression. Okay, bawah ni memang totally to resist tension. And then for C, this is flange section of either T or L shape with tension steel and with or without compression steel. So dia mungkin akan ada compression steel lah. Meaning to say, compression steel ni akan duduk kat atas Kalau ada, dia akan perhaps dekat sini lah. Oh my god, benda ni sangat teruk. Contohnya lah, my example mungkin akan ada kat atas. So, kalau ada compression steel. Okay, so for this kind of like T or L, this one adalah untuk continuous beam. Okay, so bila ada continuous beam, akan jadilah macam ni. Jenis-jenis T dan L ni keluar. Alright. Fahamkah? Any question? Ada soalan nak tanya? Tak ada. Tak ada, proceed je I assume you faham lah. Never mind, tak faham boleh tanya lagi. C tak faham? Okay, C tak faham. Okay, Jocelyn nak tanya, also can tanya. Jocelyn, you raise a hand, you nak tanya soalan ke? Tak ada. Okay, tak apa. You tanyalah. Okay, so for C, okay, sebenarnya C ni kita tak okay, kita tekan. So for C sebenarnya kita tak belajar. Jangan risau awak jangan risau. C ni memang kita tak belajar. But okay, this one, if you still remember sebelum ni, you ada belajar what we call it? You ada belajar indeterminate structure. Is it? Yep. Indeterminate beams, that kind of thing. So normally for C adalah untuk that type of beam. Okay. So dia macam bersambung. Dia ada jenis T macam ni. Okay. But this yang top here ni, semua ni adalah beam juga. Okay. Yang ni semua ni, dia termasuk dalam beam structure. Okay. So dia akan connected together macam tu lah. Okay. This one you jangan risau. Ini kita memang tak ada belajar kira. Kita belajar kira this one sahaja. Yang ni sahaja. Okay. But this one, kita akan kira macam mana nak cakap? Kita akan belajar yang ni. Kita juga kena kira to make sure that dia tak jadi macam ni. How to say? Okay, so sebenarnya kita nak avoid no, this is not avoiding. Okay, this one sebenarnya lah, if you constructing something, you nakkan you punya design tu, you nak beam size you kecil. Okay, so ada possibility you kena design dia jadi macam ni lah. Okay, but if beam size you doesn't matter, besar pun tak kisah, as long as it can resist a load. So this type lah yang the first one here. Okay. Any other question? Sebelum I short-short sendiri, I pun pergi assumption. Ya, banyak assumption, jangan risau. You akan belajar. Nama saya Miss Assume kan. So saya akan bagi banyak assumption lah. Alright. Dia suka jadi macam ni. Not funny. Alright. Okay, material properties balik So, ini tak ada apa-apa lah. Ini sebenarnya saya rasa saya dah explain juga tadi. Sebelum ni punya kelas dan juga yang tadi But sikit saya nak cerita pasal konkret. So, you dah tahu mild steel dan juga simbol for steel strength FY So you know the strength for mild steel is 250. Okay. And the second thing that you have known is for high yield steel, the FY dia 460. Okay. But for concrete, so concrete 28 cube strength So kita ada C30, C35, C40, C45, C50 dan seterusnya. Okay, so C ni adalah dia punya concrete grade lah. Kita panggil C kat situ depan tu. So what does it mean by C30 and so on So maksudnya so this is in a simpler view What does it mean by that? So if you look at here, you nampak ada concrete grade. Okay, so C7.5, C10. So C7.5 means that the strength is 7.5 Newton per mm square. Okay, sama juga kalau C25 means the strength is 25 Newton per mm square. So kalau orang cakap the strength of concrete is we use concrete grade C25. So you dah tahu dah the strength is 25 Newton over mm square. Okay, so itu maksud dia. Boleh faham kah? Senang je kan? Okay, so ini tak payah ingat apa-apa lah. You nampak nombor depan ni, you dah tahu dia punya strength dia berapa Alright. So, I proceed lagi. So, here we have a characteristic design loads. So, from clause 2.4.1. So, kalau you ada BS, you boleh search for this clause. You boleh cari sendiri. You boleh tengok load apa yang ada. Okay, so here I show you we have a dead load, imposed load atau live load, and also wind load or lateral load. Okay, sama je. Okay, so for dead load, dia punya simbol adalah GK. G and subscript K. Okay, so GK, you know that dead load adalah dead load lah. Okay, structure yang cannot be move So contohnya memang something yang memang melekat dekat situ lah. For example, the structure itself adalah that load. Okay, and then we have the imposed load, which is people, furniture, equipments, blah blah blah, and the symbol is Q with subscript K. Okay, and also wind load, WK, W with the subscript K. So this one depends on location, shape and dimensions of building. So if you only design a one-story structure, we don't really care about wind load. Wind load ni normally for high-rise building. So baru kita kira. Or building yang maybe dekat dengan laut ataupun a very typhoon punya kawasan. So baru kita akan kira wind load. If not, we just ignore. Okay. Alright, penatnya. So this is table daripada BS lagi. Okay, so this table you nampak dekat sini. We have like the first one, dead and imposed load, dead and wind, dead and imposed load, and wind number 3. So for the first one, we see that dead and imposed. Okay, so normally this is what we going to use for a simple type of building. Okay. So normally kita akan ambil select 1.4 as sebab kalau you tengok dekat atas ni, the design load, characteristic load times partial safety factor. Partial safety factor. Okay, so partial safety factor ni, ini adalah nombor-nombor ni semualah. Okay. So 1.4 ni adalah safety factor ni. So normally kita akan ambil adverse terus. Okay, and also for impose kita akan ambil adverse terus lah, which is 1.6. Okay, so 1.4 and 1.6 for imposed load. Okay, so the formula daripada this apa nama benda lah ni? Table ni. So actually it will produce apa nama benda lah ni? Formula. Okay. So formula for this thing, which is W here means ultimate design load. So here ini adalah safety factor tadi. Okay. Kenapa dia hilang? Okay, safety factor tadi. So 1.4 GK plus 1.6 QK. So tadi kita dah refer to that table. It shows that for adverse situation, it should be 1.4 times GK, which is the dead load. And 1.6 is the safety factor again for imposed load. and QK adalah imposed load. Okay. Any question? Ada soalan nak tanya? Fahamkah? Everyone okay? Semua okay ke? If you're not okay, you can ask Boleh raise hands, can type here also, can do whatever you want lah. Alright, so no question. What does the letters mean? Which letter? You can always buka je your mic and ask. Letter yang mana you?
All of the letter.
Which letter?
The formula.
Which one? This one kah?
Yes.
Yang ini kah?
No, the G, the Q.
Oh. Okay. G tadi kita ada tengok dalam previous slide kita. The G is this one. That load. Okay. So that load ni usually bila kita kira GK ni, okay, bila kita kira, usually in the question dia dah bagi GK. Usually okay, kalau in real life lah, GK ni, value GK ni tak ada siapa nak bagi. Okay, but engineers normally dia dah ada macam calculation of that load dia berapa. For example, kalau katakan dia nak build a 1-story building, dia dah tahu dah that load dia berapa. Okay, by this size and this size. So dia dah ada the guide that already calculate the value of that load. So dia dah tahu whatever that they want to construct. Sebab this is what we call like a simple bising ini macam simple building lah. Bukan kita nak cuba bina KLCC. Kalau KLCC, the engineer have other way to calculate the value lah. But for normal building, contohnya dia nak bina apartment 32 tingkat. So dia dah ada value of that load already. Okay, so semua dia dah ada value tu. So dia tak payah susah lah. Okay. Yeah, like that. Okay. So for G ni adalah that load. QK ni adalah imposed load. Okay. So and this 1.4 ni yang kita tengok tadi, dia punya safety factor 1.4 and 1.6. Okay. So 1.4 and 1.6. So this one is the safety factor dia. Okay, so bila masuk dalam the formula, so it become like this lah. Alright? Clear? Clear? G is that nak? Yes. Alright. So ini pun, formula ni pun akan we going to be use it repetitively sebab dalam kebanyakan semua design kita akan pakai this formula. So I rasa you akan ingat lah. Memang dalam kepala je. Alright. And the next formula we're going to see is the ultimate design moment. So bila you dah dapat dia punya force ataupun ultimate design load, so maksudnya load ni adalah force lah kan. So kita dah ada the force which is the load lah. Okay. So we need to find the moment. So if you still remember, I'm not sure whether I ever explained to you. If let's say M sama dengan WL square over 8. I rasa I pernah explain kot. If let's say you have this kind of load yang sama. Okay. So bila you kira, you tak payah susah-susah nak buat BMD, SFD. Okay, ultimate design load ni sebenarnya calculation of maximum bending moment. Okay. Ultimate design load ni, ultimate design moment ni adalah maximum bending moment. Okay, so kalau you masih ingat, ini adalah SFD. I terbalik. Oh man. Should be like this. Okay. Ini adalah SFD. And the BMD going to be like this. Kan? Ni BMD. Alright. So BMD you ni, teruknya aku. Kalau you masih ingat lah. So maximum ni adalah this value. Okay. So kita boleh terus pakai formula. From the value of W yang you dapat sebelum ni, you nampak W kat sini, ultimate design load you ni, you masuk dalam this formula, W ni you akan boleh kira directly, provided that the loading adalah uniform macam ni lah. Okay, uniform. So bila dia uniform, dia sama, so means you can simply use this formula. Okay, to calculate the ultimate design moment. Okay, so I rasa I ada share dengan you my slide, so you boleh tengok slide tu lah for explain slide yang ni lah yang pakai, so you boleh tengok kat situ So and also here we have the value for main still. Okay, sorry, bukan main still, so ultimate design moment, main still pun masih lagi this one ultimate design. Okay, so under main still, so you nampak kat sini MU, so ini adalah design ultimate moment resistance. Panjangnya. Okay, macam ni senang cerita. 0.156 you see here, this is the maximum value. Okay, maximum value. Okay, so maximum value, you must make sure that maximum value is not reached. So maksudnya, okay, you kena guna this formula, you akan comparekan dengan the early value of M you ni, ultimate design moment. Okay, so ultimate design moment you perhaps you akan dapat lah some value and you have to calculate the value of MU, which is the ultimate design ultimate moment resistance. Okay, so this value adalah maximum. So MU yang you kira M ni, ultimate design moment yang you calculated earlier, must not exceed ultimate moment resistance. Tak boleh. So M mesti less than MU, sebab ini adalah ultimate yang boleh resist. Dia boleh resist sebanyak ni sahaja, sebanyak value yang you dapat MU ni. Maksudnya bila you design beam, bila you dah assume you pun dapat. So you pun tengok sebenarnya beam yang you dah design tu, yang size macam tu can only resist this much of moment. Okay, but then the moment yang you kira earlier, because moment yang you kira ke ultimate design moment ni is the moment yang produced by loading yang you letak dekat atas beam tu. So you must make sure that beam yang bersize yang you dah kira tu, size macam ni, boleh resist moment daripada loading. Okay, which is your M. Okay, M tu adalah moment dari loading. MU ni adalah moment yang boleh resist oleh beam yang bersize macam ni, because you dah ada the breadth, maksudnya dia punya, ini adalah B breadth dia, and then you dah ada depth dia. Okay, so size macam ni boleh resist banyak ni je, tapi kalau you letak loading terlampau-lampau, so dia tak boleh resist, macam tu lah. Okay, so you must make sure M must be less than MU, or MU must be bigger than M. Okay, so bila you dapat macam ni, MU lebih besar dari M, which is dia akan jadi singly reinforced. So kalau you masih ingat tadi I pernah cakap pasal singly and doubly, ingat lagi? Kalau doubly tadi dia ada apa I panggil benda tu? Dia ada compression bar. Okay, so singly macam ni lah. So you ada, astaghfirullahaladzim, buruk korang reda je lah aku punya tulisan. You nampak kan conteng? Guys?
Nampak.
Nampak? Bagus.
Nampak.
So kat bawah ni, okay, so ini tadi I ada cerita kan. So kalau macam ni je, kita panggil dia as singly. Okay, because dia ada tension bar. Alright. Okay, however, kalau macam ni, dia ada bar lain kat atas. 1, 2, 3. So ini kita akan panggil, dia ada compression bar, and also tension bar. Okay, So, bila tension and compression bar, so ini kita panggil dia as W. Okay. So, kita nak, sebab kita belajar, limit kita belajar lah for our syllabus is sampai singly sahaja. Okay, so kita mesti make sure that the value yang kita dapat ni is MU must be more than M. Okay, kalau value kita dapat tak macam ni, maksudnya soalan tu salah ataupun awak salah kira lah. Okay. Tu je. Alright. So, jangan risau W kita tak belajar. W kalau you nak belajar secara lebih, you ambil degree lah. Mungkin you akan belajar W. Alright. So, next. Faham Apa saya merepek? Kalau tak faham boleh terus tanya Jangan tunggu saya tanya lah. Awak tanya terus dalam chat. Nanti saya baca, saya jawab lah. Alright. Alamak. Kenapa dia lari ni? Okay, never mind. So, seterusnya. Okay, when you already check bila you dah dapat value M less than MU. Okay. Ataupun MU bigger than M. Sama je lah Okay, so maksudnya okay. Ini untuk checking sahaja. Okay, this thing only for checking. Okay, so you kena dapatkan K, the value of K. K ni tak ada nama. Dia adalah coefficient. Okay, coefficient. Memang tak ada nama. Saya pun tak tahu nama dia apa. Dalam BS 8110 pun tak cakap K ni nama apa So, we take it as K lah. Okay. So, K, the formula is equal to M. So, M ni tadi, kalau you masih ingat, it is ultimate design moment. Okay, kalau you masih ingat Right. Oh, ada kat sini. Oh, ada. Okay, sorry. So, and then FCU. Oh, I lupa nak explain. Man. Sorry. I terpaksa ke belakang balik. Okay, you ingat tadi yang I cerita pasal concrete grade ni tadi? Sorry I lupa nak cakap. Okay. 7.5, 10 ni semua kita panggil dia FCU. Okay, so bila dia cakap FCU equal to 15 Newton over mm square. Okay, so maksudnya 15 this one lah. Okay, so FCU adalah symbol for concrete strength. Okay, FY for steel strength. FCU concrete strength. Okay, so serabut lah aku ni. So FCU ni adalah concrete strength. Okay, so B adalah breadth and D adalah effective depth. So nanti kita akan tengok yang mana satu B, mana satu D. I akan explain balik lagi. Okay, so that is for K, the coefficient. So normally lepas kita kira K terus kita kira Z. So sebenarnya kita kira K, this coefficient is to calculate Z. Okay. So, sekejap. Lupa pula nak cakap. So, that's why kita kena calculate K. Okay, and kita mesti make sure that the value of K ni must be less than K prime. So, kalau sebenarnya, if you still remember, tadi masa kita calculate M, I kena turunkan. Masa kita calculate, oh man, kenapa dia tukar sendiri? MU equal to 0.156 FCUBD square. Okay, so tadi I dah cakap kan, MU ni adalah maksimum, betul Okay, so kalau kiranya, sebenarnya lah, okay. How do I want to say this? Sebenarnya, this formula, dia boleh turn to jadi macam formula ini. Sebenarnya. Kalau dia sampai reach the K prime. K prime ni K maximum lah, which is 0.156 ni. Okay, so, okay, how I buat macam ni? So, M ni I leave it there. M tu I biarkan kat situ. So, K, FCU ni akan beralih sana kan? FCU BD square sama dengan M. Okay, sama tak? Kalau you tengok ini dan ini. Sama kan? Okay, kalau you tengok K, okay, abaikan K lah sebab ini 0.156. FCU BD square. Okay, so kalau you tengok sini, So kalau K ni adalah K prime which is the maximum, dia akan jadi macam formula inilah. 0.156 adalah K prime. Okay, sebenarnya it just for macam mana nak cakap dengan you? So bila you kira benda ni, kalau memang you dapat M is less than MU, so value of K you takkan lebih daripada K prime. Sebab K prime ni adalah 0.156. Sebab daripada awal lagi you dah kira 0.156, you dah make sure that M ni less than MU. So K you takkan lebih dari K prime. Boleh fahamkah? Kalau tak faham, I tak tahu lah nak cakap macam mana. Nak cerita pun susah. Faham or not? Do you guys understand? Okay, so we only have like 10 minutes to go. Okay, so I hope that you understand on that. So after kita kira the value of K, so kita nak kira the value of Z sebab sebenarnya kenapa kita cari this coefficient K, because we want to find Z. So Z ni sebenarnya adalah lever arm. So lever arm ni is a perpendicular distance between the line of action of couple forming compressive and tensile force in a section. So macam katakan you ada beam macam ni. So top here is tension. Okay, bawah ni adalah compression. Salah, terbalik. Apa aku ni? Pada balik. Okay, atas ni adalah compression. Bawah ni adalah tension. So, but we don't know dekat mana tension, kat mana compression. Okay. So, kita nak tahu perpendicular distance. Maksudnya distance between line of action of couple forming compressive and tensile force in a section. So, ya kat mana tension, kat mana compression, berapa jarak perbezaan dia. Okay, so that's why we need to calculate the lever arm. We need to calculate dekat mana compression and tension tu actually meet up together lah. Macam tu Alright, so that is Z. So Z, the formula is D. So D is effective depth. So kalau you perasan dari tadi I cakap effective depth. Effective depth ni tak sama macam depth. Depth tu adalah height. Effective depth is a different story. Nanti I explain. So 0.5 plus square root 0.25 minus K over 0.9. Okay. So that is the formula. And also we must make sure that the value of Z is less than 0.95D. Okay. Ini memang value dia, bukan I yang buat. Okay. Mesti lebih rendah pada 0.95D. Okay. Kesian korang. I rasa you tak faham kot. Tak apalah. Alright, so this is the reason why kita nak limitkan K prime to 0.156. Tadi you ada nampak kan, I beritahu K prime is equal to 0.156. K prime adalah maximum, is a limit. Okay, so this is the reason why. Okay, by limiting K prime to 0.156, BS 810 implies that depth does not exceed 0.5D, hence the steel in tension will reach its ultimate stress before the concrete fails in compression to avoid sudden failure. So if let's say depth tu not depth NA tu maksudnya bukannya tak ada. Depth yang kita tak tahulah. Okay. Kita must make sure that the depth, maksudnya effective depth kita tu tak exceed 0.5D. D tu depth juga. Macam mana nak cerita? So, okay, for example macam mana? So, still that the steel in tension will reach its ultimate stress before the concrete fail. So, kita tak nak concrete fail. So, kalau katakan bila kita design, kita dapat value K lebih daripada K prime. Ataupun M is less than, is bigger than MU. Okay. Dia akan fail. Memang akan fail. Unless kita design dia as doubly. Okay, kalau kita design dia as singly, memang akan fail. Macam tu je lah dalam bahasa senangnya. Okay, so bending ULS. I rasa kita dah nak habis lah ni. Allah, lagi. Allah. Belum habis. Banyak lagi. So bending UL. So bending UL ni tak ada apa-apa. It's just that dia cerita a little bit about simply supported rectangular beam are designed so that the concrete blah 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 above the natural axis is capable of resisting the induced compression, and tensile reinforcement capable of resisting the induced tension is introduced below the neutral axis. Okay, so yang maksudnya neutral axis ni adalah axis yang tengah-tengah ni lah, maksudnya betul-betul dekat tengah neutral axis. Maksudnya sekarang half of it ini adalah dalam compression. Okay, kalau you ingat lagi lah, you belajar masa part tu, bawah ni tension. Okay, you ingat lagi diagram ni. Okay, so this one, ini adalah simplified stress diagram at failure. Okay, maksudnya bila reach ultimate limit state. Maksudnya maximum. Maksudnya K tu lebih besar daripada K prime ataupun M U is bigger than MU is less than M. Okay. So this is what happened. So you boleh nampak dekat sini. So ini akan jadi compression dan tension akan jadi sangat-sangat sikit. So you punya beam akan putus. Okay, so dekat sini, okay, resistance to tension tak ada. Memang tak ada langsung. Okay. So beam you tak balance. Okay, so that is the reason why kita kena letak bar to resist this thing. Okay, to resist tension dekat bawah ni. Kalau beam you hanya semata-mata konkrit saja, nothing to resist the tension. Okay, bila dia sampai dekat maximum without reinforcement, this is what will happen. Okay, so without the reinforcement ini akan jadi. So bila you tambah reinforcement akan ada tension yang to cover up bahagian bawah ni lah. Okay. So, and then we have the last formula. Bukan last formula lah. Last formula for main steel untuk calculate steel. So, bila you dah dapat, okay, you tadi you dah kira K, you dah kira, apa tadi? Z. Next step is to calculate AS. So, AS here is steel area. So, area of steel maksudnya steel bar you punya area lah. So, the formula is M divided by 0.95 FYZ. Okay. So, 0.95 ni tak ada apa-apa lah, formula saja. M ni masih lagi design moment. Ultimate design moment. Okay. Okay, and then Fy adalah steel strength, if still remember. And Z adalah value yang you dapat earlier masa you kira kat sini lah. So, you dah ada value of Z. You just fill this formula. Okay, so you're going to get the value of steel area. Okay, so you dah ada steel area. Alright. So, reinforcement areas you nampak dekat tepi ni. Okay, too large an area of reinforcement should not be avoided since it will hinder, should also be avoided since it will hinder proper placing adequate compaction of concrete around the reinforcement. Okay, bukan apa. Sekarang ni awak ada beam macam ni. Okay. So, you pun letaklah bar, steel bar. Steel bar you besar gila. Okay. So, logically speaking, how you going to masukkan you punya concrete dalam this area, yang area betul-betul, sebab steel bar you memanjang ke sana. For example, I lukis lah. Steel, you punya beam memanjang ke belakang macam ni. Okay, so ni you punya steel bar. Okay. So, macam mana concrete tu nak masuk dekat area ni? Sebab you dekat tepi ni semua you akan pasang formwork. This is all going to be formwork tepi. So, you akan pour from above. Mana ada orang pour pada kiri kan? Mana ada orang pour daripada side, orang pour daripada above. So, bila pour from above, you need a gap. Perlu ada spacing here. So, kena ada spacing lah. Okay, so dia tak boleh terlampau rapat. Okay. So this is how we going to calculate macam mana kita nak tahu berapa banyak area yang kita perlu provide, but I have a simpler way to measure this one, tak payah pakai this one lah. Nanti kita belajar on that part. Okay, so lepas you dah dapat cross section area, lepas you dah dapat area this one, maksud you dah kira the value of AS here, so you dah ada value of AS. So value of AS should be 1260 mm square. For example you dapatlah satu value. So ini adalah minimum value. Maksudnya bila you provide you punya design, ini adalah value yang paling minimum. Tak boleh go lower than this. Paling sikit you kena provide sebanyak area dia banyak ni. Paling banyak berapa lah. Okay, tak kisahlah. Mesti lebih dari ni. Tapi tak boleh melampau-lampau lah. Kalau terlebih sangat, you akan over design. Which is, company you akan rugilah. Kalau you ada company. Okay, so I pun rasa I boleh ambil any number yang bigger than this. Okay, mesti lebih besar daripada value ni Alright. So any number, so macam mana kita tengok benda ni? So if you still remember, tadi I cakap miles still kita pakai R. For I tak cakap lagi. Saya tak cakap. Oh, dekat sebelah sini. Okay, tak apa. Okay, tak apa, kita tinggal dulu benda ni. Kita pergi sini. So, if you still remember, tadi I cakap pasal mild steel and high yield bar. Okay, atau high yield steel. So, R kita panggil untuk mild steel. So, for example, kalau you nak bagi tahu orang, you pakai mild steel. Size dia adalah, for example, ini size Ini size. Okay. For example, size dia adalah 25. So, you letak R25. So, semua orang tahu, bukanlah semua orang, mostly orang dekat site tahu, R ni adalah mild steel, 25 ni adalah size dia. Okay, R25. So, ini adalah diameter dia. Maksudnya, you punya reinforcement bar, diameter dia adalah 25 mm. Okay, so that is the diameter. Okay, R ni adalah mild steel. And for Y is for high yields bar. So, for example, you pun letaklah Y16. So, everybody know that this is Y is high yield steel, that the diameter is 16 mm. Okay, so this is high yield steel, diameter dia 16 mm. Okay, R adalah mild steel. Okay, so bila you tengok kat sini, for example, here I have minimum value of steel area 1260. So, I boleh tengok dekat sini mana value yang lebih besar dari 1260, but not too big. Not too much bigger than value 1260 ni lah. So, mungkin I boleh ambil this one. Okay. And I know that what I'm going to use the high yield steel ataupun high tensile steel. So, I pun tulis 3Y25. So, orang akan tahu you akan pakai 3 numbers of bar, high yield steel, and 25 mm diameter. Okay. Any question on this?